Joining us today on Blackbird TV is John Bouley from Furnace Brokers. John's an expert in furnaces and ovens and in all things heat treating. John, thanks for joining us.
Oh, thank you for inviting me. I'm glad to be here.
I wanted to ask a couple questions. Again, it's the famous question of what's the difference between an oven and a furnace. John, can you briefly just describe what that is for us?
So an oven is sheet metal construction sandwiched around insulation. So it's very, very light duty. A furnace is steel construction, and the interior could be brick or lightweight fiber, but it's very, very heavy duty construction.
Okay, so I'm going to ask you to compare these two heat treating machines, I'll call them for now. This first one is in Wisconsin, and if you look at this, it's big, it's steel, and it's got a belt on it. Is this thing an oven or is this a furnace?
This is an oven for a couple of different reasons. One, the temperature, according to the data tag, is a maximum of 500, which would put it in the oven category. This is sheet metal construction, which defines it as an oven. And the next one, it's a sinterite belt furnace. And this runs at a very, very high temperature, well over 2,000 degrees. And this is the entrance to the furnace. And again, a furnace is heavy duty construction. So this is the parts to be sintered being put in. And sintering is you basically take powder and you form it into something. Now, in this case, it looks like there's some kind of gears. When it goes through the furnace, it basically melts this powder that's been compacted and it makes it a solid piece of steel. When it was first introduced years ago, the auto companies were the clients, and they wouldn't buy it because they were so afraid of that powder just breaking. You can't make that. You can't make it as strong as a regular piece of steel. That's impossible. And it took a lot of heavy selling. But if you can imagine, if you had a machine, all of those gears, how much labor, how much wasted material. So this sintering is a big deal in industry. So anyway, back to this furnace. This is the entrance, and once it's been heated, and whether it's sintering, whether it's annealing, whether it's hardening, it has to be cooled down. Some products you can just take the belt right out and let it air cool. But in this particular one, what you see is the exit end of this same furnace. And prior to where the open belt is, that's a cooling chamber. So it's a double wall chamber that's water cooled. So the parts are, say, for conversation's sake, 2,000 degrees coming out of the furnace. And by the time they end up outside the furnace, they're at room temperature. So the belt is traveling very, very slowly through, but it goes through this water-jacketed cooling chamber to get cooled down, and then it comes out to be unloaded or dumped into this bucket.
Yeah, and on this big furnace, as the appraiser, what are the parts that I want to measure, understand, write down, and put into my description for this sintering furnace?
On any furnace, the inside working dimensions are critical. So in the case of this, you just measure the belt. How wide is the belt? But as important is the height above the belt. In other words, how much could you fit through there?
How much goes through the gap? How many pizzas can you put in?
Usually they have it, like in this particular case, they have an exhaust stack there. But if you notice, they're limiting how much can come through there. So that would be a good thing to measure. In other words, it looks like it's 3 or 4 inches high. So whatever it is, you say 3-inch high, because you know you can't get anything higher through there. And then you want to measure the heated length. In this particular type of furnace, it's kind of difficult because sometimes it's not really defined what the heated length is. So if nothing else, just measure the box itself.
How long is this thing?
How long is the box? Just the box.
Right.
And if you said, well, the box is 8.5 foot long, I might make the assumption, I have to look into pictures, that the hot zone's probably 8 foot long. And The length of the cooling would be good to have, but it's not critical. What's more important is the heat. The width, the length, and the height.
Right.
And whether it's gas or electric.
Okay.
And the maximum temperature is always critical if you can find, a data tag, because furnaces run all over the place, and the higher the temperature, the more they're worth. So it's kind of critical. And but most of the furnaces you're going to run into are 2,000 degrees on down. The ones that operate above 2,000 start to come into a little special place where, above a certain temperature, they have different types of heating elements. They have different types of probes. It gets much more complicated. So the maximum temperature is critical. The biggest mistake is saying, well, the temperature control goes up to 2,400. Yeah, the controls come out of the factory to fit a bunch of different furnaces. So if the control goes up to 2,400, that means nothing. This could be a 1,800 degree furnace. So be very, very mindful of that.
Good pro tip.
One tip.
Go.
There's a what they call a lead wire that comes from the temperature control to the probe that's in the furnace. If you're ever looking at a furnace that has a green lead wire, the probe inside that furnace, it's actually feeling the temperature, is made out of platinum. And one probe to a scrapyard will bring over $1,000.
Well, there's a pro tip for you auctioneers out there. Let's look for those.
Means money.
Green means money. Wow. We're getting nuggets of brilliance today, John. So
it's platinum. And basically, if you just took that probe out, it's like, the size of my glasses here. It's really thin wire. 2 wires, even thinner than this. 2 wires going in. And it's $1,000 just for scrap. So to buy that is $2,000 or $3,000.
Is that something that you can reuse? Let's say that the whole furnace is scrap, but the probe is okay. Does that mean that the salvage value of that we're starting at $1,000 just for the probe?
Probably.
Fantastic, brilliant, really good information. Let's go back to this Wisconsin real quick, because we've talked about the furnace, and now let's talk the Wisconsin. To a layman, it looks the same. It's big. It's got a belt, and this is not a furnace because of the temperature chamber, right? It only goes to 500 degrees.
So that means it's an oven.
That means it's an oven.
Operate at 500. They're not max temp at 500. So that would be the first clue.
Right.
It's an oven. Anything 1,000 degrees on down is probably an oven. Broad statement. So this works the same way as the belt furnace. You put stuff on the belt at one end and it comes out the other. But in most cases, ovens don't have cooling chambers. They go in and they come out. And the exit area might be extended out 4, 5, 6 feet to give the parts time to cool down in the open air as they come out. So at 500 degrees, a thin part would cool down in 3 or 4 minutes to room temperature. On occasion, you'll run into belt ovens like this that will have cooling chambers. They may have fans blowing air on it as it comes out, and it might be in a cooling tunnel. But most of the belt ovens that you'll see don't have any cooling chambers. They just put it in, take it out.
And if it's there, describe it. Last question, John, to the collateral side of why we have these interviews. Do these make good collateral? Can the bank get their money out of these if there's a problem, if they need to sell them?
This is excellent collateral. On our new side, delivery on something like this is 16 to 20 weeks, even in these times. So this is something that should sell fairly easy.
How about the sintering furnace, the blue one? Does that make good collateral? It's a little longer, a little bigger.
It's good. It's good collateral. It's a little more smaller market for that type of furnace, but because it's doing sintering, it could do other processes. It's not just for sintering. So yes, it would make good collateral.
Good information, and I really appreciate your expertise, John. Thanks for joining us today.
Oh, glad to be here. Thank you very much.